Okay, we are back. 3.2, the remainder theorem. Okay, before we get into what the remainder theorem actually is, oh boy, recall. Do you remember how to do long division? It's been a while, hasn't it? Let's review this, okay? Long division, I have 430 divided by 8. Okay, so I have 8. It's not going to go into the first one, so I go 5 here. That's 40. 43 minus 40 is 3. And I have 30. Okay, how many times does 8 go into 30 without going over? 3 times. Okay, 8 times 3 is 24, right? I'll ring a bell here. Nomenclature. This is your remainder. Remember this, right? Can you identify the following? Okay, we know the remainder, that's what's left over. Quotient, we know that's the result of division, so this is your quotient. Okay. What's the divider? What's the divisor? What's the dividend? The divisor is what is doing the dividing. Well, we wouldn't be doing dividing without this 8, so this is your divisor. And therefore, this 430, that is your dividend. There you go. Okay, now that we got that out of the way, okay, polynomial long divisions. You can divide polynomials by other polynomials using the same long division process that you know. Okay, just bear with me for now. I'll read this. The result of the division of a polynomial in x, p of x, by a polynomial of the form x minus a. So this is your binomial, where a is an element of all integers, is p of x divided by the binomial, q of x, which is your quotient, plus r, which is your remainder, divided by x minus a. X minus a is your divisor, where q of x is the quotient and r is the remainder. Okay, we'll hold that off for now. Let's do a couple of examples and we'll come back and show you how to put it into that notation. Example 1. Divide the polynomial p of x equals x to the fourth minus 2x cubed plus x squared minus 3x plus 4 by x minus 1. So remember, we're thinking about the form x minus a. This will be important later, okay? Here are some instructions on how to do it. Write the dividend and divisor in descending order of the variable. So you got to check first, very important. Insert 0 coefficients for the missing powers of the variable. Very important. So like placeholders, perform the long division process and be extremely careful in the subtraction step. Watch your signs. For example, 8 plus x squared would need to be written as x squared plus 0x plus 8. Okay, so let's do this first example. So I'm going to line it up like this. Here's my dividend. So the thing that is being divided. Okay. And then here's our divisor. Divisor is x minus 1. Okay, so since I have two terms here, x minus 1, I'm going to look at the first two terms here. Okay, and x minus 1 goes into x to the fourth, x to the 3 times. So I'm going to put an x to the 3 here where I'm matching all the powers. Okay, so x minus 1 times x to the third, that's x to the fourth minus x to the third. And remember, we are subtracting these. I'm going to put brackets around here. Subtract. X to the fourth minus x to the fourth is 0. And negative 2x cubed minus negative x cubed. Okay, so that's negative 2x cubed plus x cubed. That's minus x cubed. Okay, very important that we get this step correct. And then plus, I'm going to bring this x squared down. Next part. X minus 1 goes into negative x cubed plus x squared. How many times? Minus x squared times. So that's negative x cubed plus x squared. And remember, we're subtracting this. So negative x cubed minus negative x cubed is just negative x cubed plus x cubed, that's 0, and x squared plus x squared, x squared minus x squared, that is 0. Okay, and then for this part, since we have a 0 in this place, I'm going to put a 0 here. Okay, I'm going to bring this 3x down. And then I'm going to bring this other part plus 4 down because we have a binomial. We need to match it up. Okay, this one, a minus 3 goes right there. So that's negative 3x plus 3. And we're going to subtract negative 3x plus 3x is 0. And then 4 minus 3 is 1. Okay, so let's rewrite all of this as x to the 4th minus 2x cubed plus x squared minus 3x plus 4. Remember, we're dividing by x minus 1. That equals x cubed minus x squared minus 3. So this part right here, the quotient, plus 1 over x minus 1. That's the remainder divided by x minus 1. This matches the form p of x divided by x minus a, which is your divisor, equals the quotient plus, this is your quotient, plus the remainder divided by x minus a. Identify the restrictions on the variable. Because of this part right here, so this part right there, x cannot equal 1. Verify your answer that p of x equals x minus a times q of x plus r. So we have all our pieces parts over here. So p of x, x to the 4th, minus 2x cubed plus x squared minus 3x plus 4. Whoa, 3x plus 4 equals x minus a is x minus 1. That's your divisor. The quotient is x cubed minus x squared minus 3, and my remainder is 1. All right, this is grade 10 review, just polynomial multiplication. Okay, left side equals right side. Done. Next page. All right, give this one a try. So pause the video here, give it a try, look back, and see if you did it, okay? Good. Next step, let's move on to synthetic long division. Synthetic because it doesn't look like the typical long division that we would do. It's actually a short form of long division involving a binomial divisor that uses only the coefficients of each term and involves fewer calculations. Much cleaner, and it's much faster. Just a note for the divisor, we're only talking integral factors here. So the divisor is always in the form x minus a. So x minus 2, my a value is 2. So the divisor is what's going to go on the outside. So 2 is here, and then we set up this long L-shaped. Okay, put the coefficients of your polynomial on the top row here. So 1, x cubed, so just the 1. Negative 3x is negative 3. Oops. Oh yeah, be careful. I almost made that mistake. We have to rearrange this in order. So it's plus 7x squared is just 7. Then negative 3. And then the 4. So remember, I almost made that mistake, so I'll put it here. Descending order of degree. Okay, remember that. Super important when you do the synthetic division. Okay, now that we have it set, okay, for this division, we're thinking a little bit backwards in that because of synthetic division and because of this fact, x minus a is 2, not negative 2. We actually add when we're doing these divisions, okay? So 1 is here. 1 plus 0 is just 1. We start off, okay? 2 times 1 is 2. 7 plus 2 is 9. 2 times 9 is 18. Negative 3 plus 18 is 15. 2 times 15 is 30. 4 plus 30 is 34. Okay, where did we see this before? This is actually the same division problem as the previous one that you just did with the U-try. Okay, what do you notice here? First, I'm going to label a couple of things so we can keep things straight. The row here, the dividend, this row, that's x cubed, x squared, x, and then this is your x to the 0 term, or your constant term, right? When you do the division, remember you're dividing out by a first degree term, so you expect to get a quotient that's 1 degree less. So this is your x squared term, this is your x to the 1 term, this is your constant or x to the 0 term, and what's this one? This is your remainder. Okay, let's write this out in full. This is the quotient, q of x. So the quotient is x squared, so q of x squared, plus 9x plus 15. And then the remainder is 34. Same 34 here. Quotient. Right here. Sorry. Same quotient. Okay? So much faster, so much easier. Less messy too. All right? All right. Next step. Investigate. Use synthetic division to divide x squared plus 5x minus 24 by x minus 1. So let's do that. So I set up, remember, x minus a, so a equals 1, so 1. And I have x squared, so I'm going to use the coefficients 1, 5x, 5, and negative 24. So 1 plus 0 is 1. 1 times 1 is 1. 5 and 1 is 6. 1 times 6 is 6. 6 goes here. And I have negative 18. Part 2 here. Same polynomial. Remember, x minus a, folks. X minus a is the format, so x minus negative 2. A equals negative 2. So a negative 2 goes out here. and 1, 5, and 24, negative 24. 1 and 0 is 1. Negative 2 and 1 is negative 2. Negative 2 times 1 is negative 2. 5 plus negative 2 is 3. Negative 2 times 3 is negative 6. And negative 24 plus negative 6 is negative 30. Okay, so this is x plus 6. This is x plus 3, our factor. That's the quotient. So p of x equals x plus 6. Let me just rewrite this again. A little bit more room. Sorry, folks. P of x equals, this is x plus 6, the quotient. And remember this part, that's another one of your factors. So that's x minus 1. And then our remainder is written as minus 18. So that polynomial p of x equals x plus 6 times x minus 1 minus the remainder 18. Likewise, over here, p of x equals x plus 3. That's our quotient. And then this one, this minus 2, that's our other factor, which is x plus 2. And then minus our remainder, which is minus 30. Okay, let's look at a little bit of review on function notation. When we have something like f of 1, right, we're evaluating for an x value of 1 in the function. So what's the result? So f of 1, that's the same divisor that we used when we did synthetic division. So let's see what happens when we do f of 1. So I'm going to take it in this form. Actually, no, I'm going to take it in the original form. Okay, that's, first let me just write it out. F of x equals x squared plus 5x minus 24. And then f of 1 equals 1 squared plus 5 times 1 minus 24. 1 plus 5 minus 24. 6 minus 24. Negative 18. Oops. Okay, well, what does this number remind you of? Well, it's the remainder, folks. And then, so let me just use a highlighter to link those two. So there's the remainder. There's the remainder. That's where it appears. What about the 1 inside the f of 1? All of this. Where's that from? Well, it's right here. That's the divisor. Okay, so you start to see a link between the two. Let's see what happens with the other example. F of x equals x squared plus 5x minus 24. F of negative 2. So that's our negative 2, the divisor. Let's evaluate. Okay, let's look at some patterns here. Negative 30. Look at that. That's our remainder, negative 30. Okay, also, what else do we got here? F of negative 2. Well, then negative 2, that's our divisor, so let's highlight these. Negative 30, negative 30. In our synthetic division, there's the negative 30. What about the x value? Negative 2, negative 2, negative 2, negative 2. Well, that's our divisor. Oops. Okay. Next page. That brings us to the definition of the remainder theorem. What we just showed you was an illustration of the remainder theorem in action. When a polynomial in x, p of x, is divided by a binomial in the form x minus a, the remainder is p of a. We can use the remainder theorem to determine the remainder without doing long division. So this is a useful thing algebraically to figure out, hey, what's my remainder? Okay, example 3. Algebraically determine the remainder when 11x minus 4x to the fourth minus 7 is divided by x minus 3. Okay, so if my divisor is x minus 3, what does a equal? A equals 3, so be careful with that, okay? So p of a equals p of 3, right? Because that's our a value. And then I'm going to evaluate 11x minus 4x to the fourth minus 7. So let's evaluate. 11 times 3 minus 4 times 3 to the fourth minus 7. Okay, and then let's evaluate that. Negative 298. This is my remainder using the remainder theorem. Let's see what happens when we use synthetic division. So first off, we have to be careful. I'm going to rewrite p of x in descending order. So 11x minus 4x to the fourth minus 7. I'm going to write it as negative 4x to the fourth. Remember, with synthetic division, I have to account for the spaces in between. I need them in descending order of degree, and I need to fill in zeros where there is no x term. Okay, so this is my polynomial. So my divisor a equals 3. So I'm going to fill in all these coefficients. Negative 4 plus 0 is negative 4. 3 times negative 4 is negative 12. 0 plus negative 12 is negative 12. So this is negative 36. Okay, and so on. Let me just finish this up. 3 times negative 36 is negative 108. That's negative 97. Negative 291. And that's negative 298. This is my remainder. And does it check with the remainder I did when I used the remainder theorem? Yes. Example 4. More uses for the remainder theorem. Solving for an unknown value. When x to the fourth minus mx cubed minus 2x squared plus x plus 4 is divided by x minus 3, the remainder is 16. Determine the value of m algebraically. So first step, x minus 3. My a value has to be 3. So remember, when the remainder theorem says p of a equals your remainder, right? So p of 3 must equal 16, which is my remainder, right? Right here. All right, so let's keep this in mind. I'm going to set up my p of 3 equals 3 to the fourth minus m 3 cubed minus 2 times 3 squared plus 3 plus 4. Okay, when I evaluate that, let me just simplify some of this. Okay, remember we said p of 3 right here. 16 equals 70 minus 27m. Let's solve for m. Okay, m equals 2. Example 5, another way to solve for an unknown value with the remainder theorem. when 4x to the fourth minus 12x minus 50 is divided by x plus k, the remainder is 22. Okay, so how does this work? X minus a, that's x plus k, or another way to think about it is x minus negative k if I'm putting it into this form. Okay, so p of negative k, okay, that's my divisor, p of negative k, and then we said the remainder is 22. That's the remainder theorem. Okay, let's start with our polynomial. P of x equals 4x squared minus 12x minus 50. Let's plug in p of negative k. So 4 negative k squared minus 12 times negative k minus 50. Okay, let's simplify all this out. Remember p of k, I'm going to bring this down here. That equals 22. 22 equals 4k squared plus 12k. Okay, and then this is a quadratic. Let's solve this quadratic. So here we go. Okay, done.